Namaskara students, welcome to V Karnataka KCET and boards. I am Diksha Kaushal, your chemistry master teacher. And students, in today's class, we are going to start the second chapter of physical chemistry, that is electrochemistry. Right? Now, this chapter is very scoring, very important, right? Yes, I know it's for some students, electrochemistry is a tricky topic because they find it very difficult to understand that, ma'am, which formula to apply and how to apply that formula. How to understand that whether it's E naught cathode or it's E naught anode, right? How to put the values, all these things we will cover, right? Okay, everybody in the chat box, very good evening, students. Very good evening. So today, firstly, we are going to talk about what is exactly electrochemistry, what we are going to study in this chapter. Second thing, now today's class is going to form the base, right? So second thing that we are going to see today is what exactly is electrode potential, right? So many students just cram the formulas, they have no idea what exactly is electrode potential, right? How can a concept of physics, that is a potential difference or potential, there in the chemical reaction, right? So we will see how the electrode potential is developed here. We will discuss about Daniell cell, galvanic cell, voltaic cell, right? All of these things we will discuss. So everybody in the chat box, are you all ready or not? Are you all ready or not? Everybody in the chat box, can I see green hearts in the chat box? Can I see green hearts in the chat box? Everybody, if you are ready. Yes, your Dosa ma'am is here. Yes, and we are going to rock this chapter today. Yes, okay, everybody. Ma'am, chemical kinetics, previous year questions when? Firstly, let me complete physical chemistry, right? After that, I'll pick up the questions together, right? Okay, after that, I'll conduct this particular sessions on your practice questions, right? Okay, guys? Yes. Now, very good. Now, let us see. Now, in this chapter, firstly, we are going to talk about what exactly we are going to study here. So, there are two terms. One is electrochemistry. One is electrochemical cell, or you can see electrochemical cell, right? Other is electrolytic cell. Electrolytic cell, right? One is electrochemical cell, other is electrolytic cell. Now see, these two cells we are going to separate, we are going to study differently. Firstly, we are going to focus on what is electrochemical cell. After that, we will study about electrolytic cell. So the basic differentiating points I am writing here, usually students get confused on these points. So first point here is, in this, chemical energy is getting converted to electrical energy. Chemical energy is getting converted to electrical energy. That means here what exactly happens? There will be a chemical reaction from which, because of the movement of electrons, there will be production of the current. Right? There will be production of the electricity because of the chemical reactions. Right? But in this case, electrolytic cell, electrical energy will be converted to, you will have electrical energy that will be converted to chemical energy, right? That means here you will supply the electricity here. You will give the electricity, right? After that, that reaction is going to happen in the beaker, right? Okay, so that is the main difference here, right? In both the cases, we will use two terms. One is anode and other is cathode. One is anode and other is cathode. Here also we are going to talk about anode and cathode. Here also we are going to talk about anode and cathode. But you know what? What is the basic difference? The signs are opposite, right? If you talk about this sign, you just need to remember one thing, that is LOAN. Now, what is this lone, ma'am? Right? L means loss of electrons, right? Electrons will be lost. There will be loss of electrons. O means oxidation. A means anode and N means anode is a negative electrode, right? So I am writing it here. There are 4 things that we need to see here. That L is loss of electron, L is loss of electrons, then O means oxidation, A means anode, and N means negative electrode. N means negative electrode. N means a negative electrode. So these are the 4 things. Okay? Loss of electrons, oxidation, anode, a negative electrode. Now, that means at anode, if you talk about electrochemical cell, anode will be a negative electrode and cathode will be a positive electrode. But when you talk about electrolytic cell, anode will be a positive electrode and cathode will be a negative electrode. Everything else is going to be same. That means definitely there will be loss of electrons at oxidation and at anode, right? So whenever there is loss of electron, that means this is oxidation is happening and that electrode will be called as anode. But in case of electrochemical, that is a negative electrode. In case of electrolytic, that is a positive electrode. Right, students? Is that clear to everybody here? Is that clear? LOAN, loan. Right? Okay? Yes, that's not a bank loan. Right? That's a loan from chemistry that you are taking. Right? So that you can clear the exam. Right? Okay. Now, next is electrochemical electrolytic difference that we have done. Now, in detail, we are going to talk about electrochemical cell. Right? Okay. So, everywhere I'll take anode as a negative. Right? Now, basically, what is an electrochemical cell? Right? In this, what will happen? Okay, I'll draw a diagram here. Right? I'll draw a diagram here. Just give me a second. Yes. Firstly, we are going to talk about oxidation and reduction. Right? Okay. So, here I am going to talk about oxidation. Right? Oxidation, as I told you, that is loss of electrons. So I am drawing a beaker here. There will be a beaker, right? There will be a beaker. And in this beaker, what you will have? In this beaker, you will have an electrode, right? You will have an electrode, right? I am drawing it by this pink line, right? That is your electrode. Now, if you talk about this electrode here, this electrode and this solution, right? Now, what we will have in the solution and what kind of electrode will be there. So, in the solution, for example, you have A positive ions, right? You have A positive ions, right? Or you can just say M positive ions. You have M positive ions, right? These are the ions, right? And here you have, let's take an example, you have Mn positive ions, okay? You have Mn positive ions. And here you have M electrode. M is the electrode, right? M is the electrode. So now at anode, what is going to happen? I told you at anode there will be, this is oxidation, which means it will occur at anode. And at anode there will be loss of electrons. There will be loss of electrons that we need to show here, right? So this is the oxidation part. Anode, you will have loss of electron. This we know from LOAN. Loss of electron, oxidation, anode, right? Now, let us see how we are going to write the chemical reactions here, right? So, loss of electrons means this metal is going to lose the electrons and convert itself into the ions. So, already you will have some ions here. Already you will have some ions in the solution, right? And there is this electrode that should be same, okay? This is also M, this is also M, right? So now what is happening? This metal from the electrode, it is losing the electrons to become ion, right? To become ion. That is called the loss of electron, right? Okay, so this is basically oxidation, right, students? So this is basically oxidation. What happened? Ma'am, what is dosa? Why they say like this? They say like this because I love dosa. That is why they are saying this, okay? Now focus here. They are not going to ask you, ma'am, Why in KCET exam the biggest question is why everyone is calling Diksha Ma'am as Dosa Ma'am? The question will be regarding electrochemistry, right? So let's focus on that. Okay, guys. So let's focus on that. Now, this is oxidation. Now, everybody in the chat box, tell me in the chat box if this thing is clear to you, right? Because every single step is important here. Every single step, right? Every single step is important here. Now, let us see. Next thing is, we know that what exactly is happening here. From this metal is losing electron and giving Mn positive ions in the solution. Already there were some Mn positive ions in the solution, and it is giving more Mn positive ion in the solution because it is losing the electrons, right? It is losing the electrons. So can I say something like this is happening? This is giving Mn2 positive ion, Mn positive ion in the solution. So can I say that it is losing the electrons? So these electrons are going to move through this electrode, right? They are going to move here. They are going to move here. These are the electrons that I am mentioning. And these ions are going to increase in the solution. Can I say this thing is happening, right? Electrons are moving on this electrode, right? And this positive ions are increasing in the solution. Earlier there were, for example, I had ZnSO4 solution, right? I will have Zn2 positive and SO4 2 negative in the solution, right? Number of positive and number of negative ions will be same. That is why this will be, earlier this should be electrically neutral solution, right? But now what will happen? After some time what will happen? This Zn2 positive is going to increase in the solution because this zinc rod will lose the electron to become Zn2 positive and SO4 2 negative will remain the same. For example, earlier I had 10 molecules of ZnSO4. So there will be 10 Zn2 positive and 10 SO4 2 negative. Now I have increased the ions because the metal is losing the electrons and becoming ions. So now after some time I will have maybe 20 Zn2 positive. Now that means Zn2 positive ions are increasing, the solution is becoming positive, right? Now students, because of this positive negative charge, because of this thing here, this negative here, this negative here, and this positive here, and this positive here, there is development of a charge separation, right? What exactly has happened here? There is development of a charge separation. There is negative, 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 positive, 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 positive. And because of this thing, there is electrode potential, right? Because of this thing, there is electrode potential. Electrode potential. This thing is called the separation. Because of the separation of the charge, right? There is development of this positive and a negative charge, right? There is development of this electrode potential, right? This is called electrode potential, that is represented by this E, right? Now, I am talking about in the case of oxidation. Here this is happening because of oxidation. This electrode potential is developing because of oxidation. So I'll say this is oxidation potential. So instead of writing electrode potential, what we will write? Oxidation potential. Okay, so you can write oxidation potential, right? That is defined by EOX, right? Electrode potential, that is in case of oxidation. Is that clear to everybody? We did the MCQ, then you can take electrochemistry. Okay, Zainab, I will focus on that thing just now because we have already started this chapter. Now let's firstly complete this chapter. Okay, so let's firstly complete this chapter because otherwise one class will be of electrochemistry. After that you are doing numericals of chemical kinetics. So better to complete this and then I will do the numericals of chemical kinetics and electrochemistry both. Right, students? Okay, Zainab? Yes. Your suggestion is accepted. Okay. Yes, everybody. Everybody. Is that clear or not? Yes. Everybody in the chat box, is that clear or not? Does it take two? There is not that much lagging that you are sitting there and not typing anything. Type something in the chat box, right? Okay, yes. Now let us talk about reduction. Okay, now we are going to talk about reduction. Reduction. If you talk about reduction, this is basically opposite of oxidation. That means this will occur at cathode. This will happen at cathode, and this is gain of electron, and this is gain of electrons, right? This is basically gain of electrons. So now, for example, you have this thing. And there is this electrode, and there is this electrode, right? And there is this electrode, right? You have this thing, and there is this electrode. Now you need to tell me that what we are going to do here. Again, I am saying the same thing, that we have M electrode, and we have Mn positive, Mn positive, not manganese. This is M raised to power n positive, right? These ions in the solution, right? Now, as I am saying that there will be gain of electrons. That means the ions Mn positive, they are going to gain n electrons, and it will become M, right? That means what is going to happen here? The ions from the solution are going to deposit on the electrode, right? Ions from the solution are going to deposit on the electrode, right? They are going to deposit on the electrode, right? This is basically is going to happen, right? So can I say that here again there is development of something? What is that? Now again what is happening? Here the electrons are gained, right? For example, here it had some electrons that were coming here, that I'll tell you from where it is coming, right? For example, here some electrons are coming, and these Mn positive ions are catching those electrons and getting deposited on the electrode, right? So we know that, for example, I am talking about CuSO4. Now earlier if I had 10 CuSO4, that means 10 Cu2 positive and 10 SO4 negative, right? That means if 5 of these ions are getting converted into copper, that means after that I'll have only 5 Cu2 positive ion, but the SO4 negative ions will remain as it is, right? So that means if some of the ions are getting converted to electrode, to simple metal, that means the concentration of these ions are going to get decreased. The negative charge is going to get increased in the solution. That means here there will be negative charge. Here you will have negative charge. There will be negative charge, right? There will be negative charge, and because of that there is positive charge here, right? There is positive charge here. Now because of this there is development of again electrode potential, because this is happening because of charge separation. That is why, and charge separation in case of gain of electron, that is why it is called reduction potential, right? That is why it is called reduction potential. This is called reduction potential. Is that clear? This is called a reduction potential, right? Okay, very good, Zainab. Now this is called reduction potential. It is called as ERED, reduction potential. Is that clear? That is ERED, reduction potential, right? Okay. Now guys, see one thing. We have talked about oxidation potential in case of oxidation, reduction potential in case of reduction. Now what is the relation between these two things? So the simple relation is that E of which thing? E of reduction of a one metal is equals to minus of E of oxidation of that metal, right? Okay, and here one more thing to write. Firstly, you should write what is standard electrode potential. If they talk about what is standard electrode potential, standard electrode potential, what is that? Everybody, what is standard electrode potential? The electrode potential which takes place at standard conditions, right? And here it is represented by E naught of reduction or E naught of oxidation, right? E naught of reduction or E naught of oxidation, right? E naught of reduction or E naught of oxidation. Okay, understood? Now, this E naught of reduction is equals to minus of E naught of oxidation. That is the relation between these two things, right? That is the relation between these two things. That is the relation between these two things. Okay, guys? That is the relation between these two things, that the E naught of reduction is negative of E naught of oxidation, right? Yes. At standard temperature, that is 273 Kelvin, right? And standard atmospheric pressure, 1 atmospheric pressure, you will have this thing, right? That is E naught. That is called as naught here, right? So E naught is already given to you in the question. You don't need to calculate it, right? Based on E naught, you also have one electrochemical series, right? Reactivity series, right? We will study about later on, right? Firstly, after this, we will also talk about one more thing, that is Daniell cell, right? So now let us talk about what is exactly Daniell cell. Daniell cell is a kind of electrochemical cell, right? So before studying Daniell cell, you need to know this thing. That is why I have taught you this E naught of reduction and E naught of oxidation before itself, right? Now let us see what is exactly Daniell cell, right? Okay, guys. Now let us see what is Daniell cell. If you talk about the Daniell cell here, Daniell cell is also very, very simple, right? So you have two beakers. Now because we have individually seen this thing, now this will be very, very easy for you. Now you have these two beakers. You have these two beakers. What we are saying that in one beaker you have this thing. In one beaker you have this electrode, right? You have this electrode, right? And you have this electrode. And you have this electrode, right? Or if you want me to make it by some other pen, I'll make it by some other pen, right? This is your another electrode, right? Now, there are few things that you need to understand here. That anode will take place on left side, right? How to remember this thing? Again by LOAN. LOAN. L means loss of electron and L also means left side. So let us write it here only. Let us write it here only on the first page. L also means left side. L also means left side. That means anode will take place on the left side, right? Anode thing you will take place. It will happen at the on the left side, right? So this is a compartment of anode. This is a compartment of cathode, right? Now in the Daniell cell, at anode side you have ZnSO4, right? That means here the solution is ZnSO4, right? And here the solution that is present here is CuSO4. The solution that is present here is CuSO4. That is the solution that is present there, right? ZnSO4 and CuSO4. Now let us see, in ZnSO4, here you have zinc, right? And here you have copper electron, right? The same kind of solution, the ions that you have in the solution, the same electrode will be present. Here also you have CuSO4, the electrode is Cu, right? Now, next thing is what you are going to do. We know that on this side, this is the anode side, right? I am writing it here. This is the anode side and this is the cathode side. This is the cathode side. Now, we are combining these two things. We are saying that at anode, what is going to happen? Everybody in the chat box. At anode, what is happening? Oxidation is happening, right? There is loss of electron. That means zinc. This zinc is going to lose the electron, right? And become Zn2 positive ion, right? Then there is this cathode. then you have this cathode. Then you have this cathode, right? Now, this cathode is going to, this copper, the copper to positive, because we know that at cathode there is reduction. In reduction, there is gain of electron, right? Because of the gain of electron, it is going to gain 2 electrons and become Cu, right? These are the two reactions that is going to happen here. First, you tell me, is this thing okay with everybody, right? Okay, so these are the two reactions. Now, let us visualize things, right? That in reality, these two reactions are happening, and because of these two reactions, what will be the effect on these two cells, right? Now, they are connected by something. I'm just drawing it like this. Okay, they're connected by a wire which is conducting in nature, right? So I'm drawing it here. Now, what is going to happen? Now let us see what is going to happen. Wait a minute. This is Zn, right? Okay. Wait a minute. Let us draw it with some other pen. I think now it's better. Now this is zinc. This is zinc. Now students, understand one thing. Visualize this thing. What is going to happen here? I am saying that zinc is losing the electron. That means this zinc electrode is losing some electron. Those electrons are moving here. It is losing the electrons. Those electrons are moving here. They are moving here in this direction, and the Zn2 positive ions are getting into the solution. They are getting into the solution, right? Now, if I had a thick rod, right? If I have a thick rod and some atoms out of this rod are getting converted to ions, that means some kind of hole will be present here. Some atoms from it has been deposited, it has been taken out as ions in the solution. That means the thickness will decrease. So what is going to happen? What is going to happen here? I am copy pasting this thing here. Now let us see what is going to happen here, right? Let us see what is going to happen here. Some of the part of this electrode is going to getting into the solution as Zn2 positive ions, right? It is getting into the solution as a Zn2 positive ions. It will be like this. Okay, it will be like this. Some part is getting into the solution as Zn2 positive ions. So can I see the thickness of anode? The thickness of anode decreases. Thickness decreases. Thickness decreases. Thickness of anode will decrease. But if you talk about this thing here, the electrons are getting in this direction. The electrons are getting in this direction, and copper 2 positive ions in the solution are catching those ions and they are getting converted to copper. That means here what you will observe, the thickness of this electrode, wait a minute, yes, the thickness of this electrode is going to increase. The thickness of this electrode is going to increase, right? The thickness of anode will decrease and the thickness of cathode will increase, right? Here you can write the thickness will increase. The thickness will increase. Is that clear to everybody or not? How the thickness is going to increase, how the thickness is going to decrease, right? That is the first important question that they can ask you, that the thickness of anode decreases or cathode decreases. The thickness of anode is going to decrease. The thickness of cathode is going to increase, right? That is the first important point. Second important point is the flow of electrons. If you talk about the flow of electrons here, let us talk about the flow of electrons here. So as you can see, the electrons are moving from anode to cathode. So you can just write electrons are moving from anode to cathode. Electrons are moving from anode to cathode, right? And if you talk about the current is always opposite to the flow of electrons. If electrons are moving from anode to cathode, right, then the current will move in the opposite direction, that is from cathode to anode. So you can write current will move from cathode to anode, right? Cathode to anode, right? So here it will move in this direction and here current will move in the opposite direction. Right, students, everybody? Is that clear or not? Yes, the current will move from cathode to anode, right? Okay. Now, I am seeing your chats. One of you have written salt bridge so many times, right? So let us see what is exactly the salt bridge. What is the need of this salt bridge, right? But before that, tell me, is this clear to everybody what we are doing here? What is happening here? How the thickness is decreasing, how the thickness is increasing here. Earlier it was like this, but now the cell is like this. Now the cell is like this. Things are getting changed here, right? Now, what exactly is happening? We know that this zinc is the electrode. The zinc from the electrode, or you can just write the zinc from the anode is getting lost and is getting in the solution, right? And here the ions of the solution are getting converted to cathode, So can I say one thing here? That here the positive charge is increasing in the solution, because here in the solution you have more positive charge, right? But in this case, even the ions from these solutions are getting deposited on the electrode. That means the ions in the solution is getting decreased, right? So that means, can I say that here the positive charge is increasing, right? Here the positive charge increases in the solution, right? If we talk about this side, if we talk about the cathode side, in this case, what will happen? You have CuSO4 solution. Example, earlier you had 1000 molecules. Out of them, maybe 50 CO2 positive ions got deposited on the electrode as Cu, right? So that means those positive ions will decrease, but the SO4, 2 negative ion, will be same only. That means in that solution, the positive ions decreases. It simply means the negative charge will increase. So here, the negative charge increases. Here you can say the negative charge increases. Here positive charge will increase and here the negative charge will increase, right? Okay guys, here the positive charge will increase and here the negative charge will increase. Okay, yes, very good. Now because of this thing, what will happen? Because of this thing, this solution is positive, this solution is negative, as I told you. That is why this is reduction potential, this is oxidation potential, right? So now because of this thing, there is electrical neutrality in the solution is nowhere to be seen, right? And this cell will stop automatically, right? But we don't want this cell to stop. So what we will do, we will add a thing that is called salt bridge that I am drawing here. It is basically a U-shaped tube, okay? It is a U-shaped tube, okay? I am drawing the salt bridge here. It is basically a U-shaped tube, as you can see here. It is a U-shaped tube, right? Okay. I think I'm not able to increase the pen size here. Okay, yes. So it is a U-shaped tube, as you can see here, right? This is called salt bridge. Now, let us see why this is added and all the properties of salt bridge on the next page, right? Okay. First thing is why this was there in the Daniell cell itself. Because in this, electrical neutrality of the solution is not stable now. It is positive, it is negative. So to maintain the electrical neutrality, you can write here, why salt bridge was used. First thing you will write, to maintain the electrical neutrality, to maintain electrical neutrality, electrical neutrality of the solution, neutrality of the solution, right? Second thing is, firstly, to maintain electrical neutrality of the solution. Second thing is, if you're maintaining the electrical neutrality, then how you are maintaining it? You are adding a electrolyte into it. You are adding a electrolyte into it. Plus there is agar solution or gelatin. Agar gelatin. Agar gelatin. Right? Viscous to increase the viscosity. Plus you will have a cotton ball here. You will have a cotton ball here. Where you will have the cotton ball? Here you will have the cotton ball, right? Here you will have the cotton ball. What exactly is this cotton ball for? So that when the electrolyte that you have added here, when it is jumping into the solution, the speed can be slow, right? So that it should not jump like this, okay, 1 ion, 2 ion, 3 ion. We want to decrease the speed so that we need to only, we don't want to increase the negative charge here. We don't want to increase the positive charge there. We want to make it neutral, right? So that is why to control the speed, we have added cotton ball here, right? Or glass wool, you can say. Instead of saying cotton ball, you can just say glass wool or cotton wool, whatever you can write here, right? Okay. Next is mobilities of cation and anion should be same. Right? So if you talk about this here, right? Here we know that in this salt bridge you have some kind of electrical in this salt bridge you had some kind of electrolyte, right? An electrolyte is made up of positive and negative charge both. So the positive charge will jump into the solution, negative charge will also jump into the solution. But if the speed of positive charge is more and the speed of negative charge is less, even then you will not have electrical neutrality in the solution. That is why the mobilities of positive and negative charge in that electrolyte should be same, right? Now example of that electrolyte is, you have KNO3, right? That's a very, very good electrolyte, right? Next is cation will jump on which side and anion will go into which side. Okay, so let us see that. We know that here positive charge has increased and we want to maintain the electrical neutrality. Now you tell me one thing, if you want to maintain the electrical neutrality, what should you do? Should negative charge go into this solution or positive charge go into this solution? Mobilities means speed. Okay, you can just write speed also here. You can write speed also, right? You can just write speed. Speed of the cation and anion. Okay, Abhishek, speed of cation and anion. That should be same. For example, cation is moving like this and anion is moving like this, right? Okay, so for example, two people are dancing on stage. One is dancing like on a very fast manner. Other is dancing very slowly. So what, the choreography will be very weird, no? So this is the same thing, right? So they should have the same speed, cation and anion, right? Yes. Now, if you have positive, this here the positive charge has increased. That means we should add a negative charge here. That means on the anode side, you can write on the anode side, you will add anion. On the anode side, you will add anion. And on the cathode side, you will add cation. On the cathode side, you will add cation. Yes, students? On the anode side, you will add anion. On the cathode side, you will add cation. Right? Okay. Okay. Yes, everybody. Clear? That was about salt bridge. Right? Okay. Any problem here? Now, any problem here? Any problem here in this Daniell cell? Then let me know in the chat box. Right? Okay. Next is, what is galvanic? What is galvanic or voltaic cell? All voltaic cell. What is galvanic or voltaic cell? Now, if you talk about galvanic or voltaic cell, right? Galvanic and voltaic cell is same as Daniell cell, right? Just the difference is, it is that Daniell cell, it is that Daniell cell, it is that Daniell cell which has, what is the difference? Which has, which thing? Which has unity concentration. Unity concentration, concentration means 1 mole decimeter per cube, right? This kind of thing. That should be your concentration. Then this thing is called galvanic or voltaic cell, right? Then this thing is called galvanic or voltaic cell. Is that clear, everybody? That is called galvanic or voltaic cell, right? Okay, that is called galvanic or voltaic cell. Now, let us see. For example, if I am saying we are applying the external pressure, on applying, not external pressure, on applying external voltage for Daniell cell. This is mentioned in your NCERT, right? For Daniell cell. On applying external voltage for Daniell cell. Now, for Daniell cell, the total potential of this cell is, it is 1.1 volt. Okay, this is the total potential of this cell, right? Now, we are saying that if your external voltage is greater than 1.1, or firstly let us say if less than 1.1 volt, if external voltage is equals to 1.1 volt, if external voltage is greater than 1.1 volt, then what are the three things that can happen here, right? What are the three things that can happen here, right? Okay, everybody. If you're, for example, you want to do something in your life, you are convincing your friend for for a party, right? You're convincing your friend for a party. Now, 2-3 things can happen. Your friend convincing power is 1.1. Now, if you are giving them that means your convincing power is less than 1.1, right? You're not giving them that much ideas about the party. You're not making them excited for the party. They'll be like, I will go or I will not go into the party. I don't think this party seems to be very boring, right? So that means if you're not able to convince them, your external potential is less than 1.1. So there is no change in cell. The cell will go as it is, right? If it was going like this, it will go like this. For example, your friend has some other plans, right? And you want to convince him that, okay, you should not go for that plan, you should go along with me. Now, your convincing power should be more, right? So, if your convincing power is less than that, so they will go according to their plan, right? If your convincing power is almost equal, right, that is equal to 1.1, right? In that case, wait a minute. So, if your, wait a minute, students. Now, if your external potential is equals to 1.1, in that case, it will remain. What will happen here? Wait a minute. This cell will stop. Why it will stop? Now you have convinced your friend that my party is really amazing, right? Now friend is getting confused. Should I go there? Should I go there? Right? He's like, okay, I will not go anywhere. I'm fed up. I don't want to go anywhere, right? So it is like you have stopped the cell. Now, for example, your convincing power is more than 1.1 volt. In that case, the things will change. The things will be opposite here. Now, what does this opposite thing means? Here we know that initially what was happening? Electrons were moving from which thing? Zinc to copper, right? So just write it here. Electrons will move from zinc to copper, right? Current was moving from, current means I. I is defined for current, right? It will move in the opposite direction, that means copper to zinc. Here we have electrons will move from move from in the opposite direction. Earlier electron was moving from zinc to copper. Now the electrons will move from copper to zinc, right? Here the current will move from zinc to copper. Current will move from zinc to copper. So that means things are going to be opposite here. Things are going to change here. This is how they are going to change here, right? Earlier the current was going in this direction, copper to zinc. Now the current will go in the opposite direction. So if your convincing power is more, if the external potential is more than the potential of this Daniell cell, in that case, it will behave in the opposite manner, right? Now Abhishek is asking this question that, ma'am, what is Daniell cell, electrochemical cell? Yes, Daniell cell, all the things that we are discussing here is electrochemical cell only, right? So I told you that electrochemical cell only we are going to discuss here, right? These are all the properties of electrochemical cell, right? And Daniell cell is that electrochemical cell where anode is zinc and cathode is copper, right? It is specified electrochemical cell. And galvanic cell is that Daniell cell, galvanic or volatile cell is that Daniell cell which has unity concentration, right? Which has unity concentration. Is that clear to everybody or not? Is that clear? Is that clear, guys? Now, next question that must arise in your head is, ma'am, how you have defined E naught of cell here? Ma'am, you are saying E naught of this entire cell. Ma'am, how can I calculate the E naught of entire cell? So let us talk about the electrode potential of cell. Electrode potential of cell. Electrode potential of the cell. So if you see this here, electrode potential of this cell will be E naught of cell equals to E naught of, at cathode what is, firstly tell me at anode what is happening. At anode what is happening? There is oxidation, right? And here it is the anode side, right? Plus at cathode what is happening? At cathode what is happening? This is cathode. At cathode what is happening? Reduction is happening. Reduction is happening, isn't it? Reduction is happening, right? Okay. Ma'am, I am having doubt in cathode and anode. It means when to say cathode, negative or positive. Just see this thing. Electrochemical cell, just remember this LOAN. Anode is negative for electrochemical cell. We are not doing electrolytic cell. We are doing electrochemical cell. For us, anode is negative, right? Okay. And anode is always on the left side, right? Anode is always on the left side. Now let us see this thing here. Let us see this thing here. Here it will be E naught. I told you one thing. Now always in your books and everywhere what you will see that E naught of cell is defined in the form of reduction potential, not oxidation potential. Even your electrochemical series is in the form of reduction potential, not oxidation potential, right? So now here what we will see, we know that this is negative, so it is E naught of reduction, and here it is at anode side, plus this is E naught of cathode, or you can just write here reduction instead of writing this thing, right? Reduction at cathode, right? So this is same. I am defining it in the form of reduction potential, not oxidation, right? And in your question also you will see the same thing, right? That means E naught of cell at standard conditions, that is equals to E naught of reduction potential at cathode minus of E naught of oxidation potential at anode. E naught of reduction potential at anode. Right? Or simply, you can just remember one thing, that E naught of cell is reduction potential of two things, cathode minus anode. E naught of cell is cathode minus anode, and you have to take reduction potential of these two things, right? You have to take reduction potential, not the oxidation potential here, right? Okay, you have to take reduction potential, not the oxidation potential, right guys? Okay, now Ma'am, how we can see that this is reduction potential, this is oxidation potential? So if you have something like this, you have E naught of A positive to A, or you have E naught of B to B positive. Now tell me which is oxidation, which is reduction. As you can see here, there is conversion of A positive to A. That means that there is +1 to 0. The charge is +1 to 0. So always remember one thing, write one thing here. In case of, write one thing here, one very important thing, right, which is from redox reactions, right? In case of reduction, there will be oxidation number will increase. In case of oxidation, here oxidation number will decrease, and in case of oxidation number will increase, right? In case of reduction, oxidation number will decrease. In case of oxidation number will increase, right? So if you can see this here oxidation number is decreasing or increasing? From +1 to 0, it is decreasing or increasing? Yes. Very good. B is oxidation. Very good. Here as you can see, the number is decreasing. Oxidation number is decreasing. Decreases means this is reduction. So here they are talking about E naught of reduction potential. They are talking about reduction potential here, right? So here, if you talk about this thing here, this is B to B positive. That means 0 to +1. Definitely oxidation number is increasing. That means here we are talking about E naught of oxidation potential. But as I told you, you should not write, okay, you just need to remember this thing, that in both cases you will use reduction potential only. So convert this thing into reduction potential. It will be minus of E naught of reduction potential, right? If they are saying this is X, right? If they are saying this is Y, so oxidation potential will be minus Y. Students, tell me, is this thing clear to everybody or not? Is this thing clear to everybody or not? Is this thing clear to everybody? Yes. Okay. Everybody in the chat box, is that clear? What we are talking about? E naught cell, you have reduction potential at cathode side minus reduction potential at anode side, right? And how you will identify whether they have given you reduction potential or oxidation potential? Always the oxidation number should decrease. Here the oxidation number is decreasing. That is why we know that this is reduction potential is given to us, right? And if by chance oxidation potential is given to you, you have to convert it into the reduction potential, right? So here this is oxidation potential is minus of this. So E naught of reduction potential of this B is going to be minus Y. If oxidation potential is Y, then the reduction potential will be minus of Y, right? Okay. Now, last topic of today is cell representation. Cell representation. Now, cell representation means, let us write the full reaction here. In Daniell cell, we had two things. At anode, zinc was getting converted to Zn2 positive by losing 2 electrons. At cathode, copper 2 positive ions were gaining 2 electrons and becoming Cu, right? And becoming Cu. These were the two things that were happening here, right? Now, overall reaction will be Zn plus Cu2 positive. This will be Zn2 positive plus Cu. This is the overall reaction. Now, they have mentioned that this is solid, this is aqueous, obviously this is in solution. This is also in solution, so aqueous, and this is solid. So, how you will represent it? The representation will always be AC. Remember AC, right? That means firstly you will write anode, then, wait a minute. No, firstly you will write AC, yes, AC. Huh. So firstly you will write anode only, yes. that is AC. Okay, you just need to remember AC, that firstly you will write anode, then you will write cathode. I don't think so you even need to remember AC, you just need to remember that thing that I told you, LOAN, LOAN. Loss of electron, left side, oxidation, anode, which is a negative electron, right? Loss of electron, left side, oxidation, anode, which is a negative electron. So anode will always be on the left side, right? So here it is on the left side. We know that anode means this thing. So that means zinc is getting converted to Zn2 positive. Whenever we are talking about conversion and the phase is changing, here we will add one line here. And this line is, these two lines are for salt bridge. Then we will have this copper 2 positive ions at cathode side is getting converted to Cu. So always you will have anode on this side and cathode on this side and cathode on this side, right? Always anode is on the left side only, right? Anode is on the left side only, right? Okay guys, okay guys. Now, I am telling you one simple trick. Now, first you need to know what is reduction, what is reducing power, what is oxidizing power. So, here also the questions are asked. Oxidizing power. What is oxidizing power? So, reducing power and oxidizing power, if you talk about, reducing power or reduction, no, it's not reduction potential. Reducing power means how good of a reducing agent it is, right? So if someone is itself getting reduced, it will oxidize the other person, right? So it will have a oxidizing power, the power to oxidize someone, right? The agent to oxidize someone, right? So reducing power means which itself is getting reduced. Itself is getting reduced. And it is oxidizing the other thing, right? And oxidizing and reducing, wait a minute, itself is getting oxidized, which itself is getting oxidized and reducing other, right? Oxidizing power. What is oxidizing power? What is oxidizing power? Oxidizing power. Oxidizing power. This means which itself is getting reduced or oxidized. If I am a good oxidizing power, that means I will oxidize something other. I am myself getting reduced, right? So it itself is getting reduced and oxidizing other. That is called the reducing power and oxidizing power. Yes, students, that is called the reducing power and oxidizing power. Is that clear? Now let us see what is the relation, what is the use here. Yes, what is the use here? Let us see that. Right? So now, for example, they have given you some reduction potentials, right? Some reduction potentials they have given you. What you will do? Reduction potential is directly proportional to the oxidizing power, right? It is directly proportional to the oxidizing power and it is inversely proportional to the reducing power. It is inversely proportional to the reducing power, right? It is inversely proportional to the reducing power, right? If they are saying that E naught of A positive to A is minus 1.2 volt, E naught of B 2 positive to B is minus 2.3 volt. They are saying E naught of C2 positive is minus 3.1 volt. Now you need to tell me the reducing power. Order of reducing power. Order of reducing power you need to tell me. Right? These kind of questions they will give you. Right? Yes, everybody? Now you need to tell me. Right? Okay, yes, I'll definitely do. But for that, you need to also have an idea about the theory portions. Right? Okay? Rohan, I will definitely cover MCQs also, numericals also. We will cover everything. Right? But for that, I don't want to see. If I start directly by MCQs, what will happen? Some of you will not have that much good concept clarity, right? Then you will feel like, ma'am, we are not able to understand the questions, right? For that, that's why I'm saying that focus on the concepts. Definitely, we have 5 months. We have 5 months, right? In 5 months, from zero to hero, you will become in chemistry. I know what is your level in chemistry. Even if you're at 0 level, I can assure you, I can guarantee you, I will make you hero. I can promise you that what you need to do is watch my lectures on daily basis, right? All the lectures that I'm taking here, you have to watch that, right? Okay. Now, students, see. Firstly, though, you need to see that whether they have given you reduction potentials only. Here, they have given you reduction potential only, right? Here, they have given you reduction potential. Here also, they have given you reduction potential because it is A positive to A, plus 1 to 0. It is decreasing. Oxidation number is decreasing, plus 2 to 0. Here, it is from 0 to plus 2. Oxidation number is increasing. That means here you have oxidation. But we want reduction potentials. So we'll write E naught of C2 positive to C. That means the reduction potential will be 3.1 volt. If it is minus 3.1 volt, then the oxidation potential will be 3.1 volt. Now we know that reducing power is inversely proportional to, or you can just write down that reduction potential is inversely proportional to reducing power. That is inversely proportional to reducing power. So the order of reducing power, the order of reducing power is going to be, the order of reducing power is going to be which thing? The order is going to be, here you have maximum. Firstly, write down the order of reduction potential. Reduction potential is C is having maximum. Then which is maximum? In the number line, ma'am, we are not able to understand whether this is maximum, this is more. Right? How to see this? On the number line C, here you have 0, here you will have minus 1.2 and here you will have minus 2.3. Right? That means 1.2 is greater. Right? So that means here it will be 1.2, that means A. Then least will be for B. So answer for reduction potential is CAB, right? Then the answer for reducing potential will be opposite of that, that is BAC, right? Firstly, maximum will be of B, then A, then C. Right, students? Everybody in the chat box, tell me, is that clear to all of you? Is that clear to all of you or not? Everyone in the chat box? Yes, very good. Very good, very good, very good. Okay, guys? Yes. Wait a minute. Okay, perfect, perfect, perfect. So guys, that was all about today. We have discussed a lot of things regarding electrochemistry. We have discussed Daniell Cell. We have discussed electrode potential. We have discussed these kind of questions also we will see in the next lecture itself, right? In the next lecture, we will talk about Nernst equation, right? Here we are just seeing that this is E naught cell, right? Here we are talking about E naught cell. If you talk about E cell, that is, just give me a minute.
2 मिनट break ले सकते हैं.
Hello. Yes. Okay, guys. So that was all about today. In the next lecture, we are going to talk about Nernst equation, where we are going to discuss E cell, right? We are going to calculate E cell from different numericals as well. And next lecture, we are going to take up numericals as well. So be ready with your notebooks and pen. Okay, then. Bye bye. Take care. See you all in the next class. And I'm waiting for your comments in the comment section and also your queries regarding chemistry in the comment section. Bye bye. Take care.